From the stimulus or the theme, a particle mass m performs simple harmonic motion. Its time period is 2 seconds. Amplitude is 0.1 meter. We have to find the value of force constant K. So this is the first question, right? Force constant. Force constant K is equals to what? This is our first question. From the simple harmonic motion and pendulum theory, we could define the time period T is equals to 2 pi root over m by k. This is actually the force constant. From this equation, we could write down the value of k is equals to 4 pi square m divided by t square. Now plug in all the values given from the equation. So this will be 4 pi square. The value of m need to be plugged in here, and this is the time of t is equals to 2 seconds whole square. Let's have the value of m is considered 0.01 kg. It's supposed to be within the quotient here, somehow missing from the quotient. So anyways, doesn't matter. We just consider the mass is 0.01 kg. Now calculate the value, then definitely we'll have a value, and the unit will be Newton per meter. This is the answer. So the force constant is 0.98096 Newton per meter. This is the value of the force constant. And the second question asked, what will be the ratio of kinetic energy to potential energy, or the kinetic energy value? And here is the assuming value. The displacement is 0.0102 meter. This is actually the question asked, like how many times of potential energy is increased or decreased over the kinetic energy. So actually this is the relation between the kinetic energy and the potential energy. Let's analyze the question. Let's start with the equation for the total energy for part B question. So total energy E is equals to half k of a square. This a is the amplitude of the motion, simple harmonic motion's amplitude, and the potential energy EP is equals to half of kx square, the displacement, and the kinetic energy EK is equals to the total energy minus the potential energy. So the total energy is half Ka square, and the potential energy half K of x square. So the main theme of the question is the potential energy and the kinetic energy relation. So we should have a form of the equation with respect to the kinetic energy and the potential energy and its ratio actually. So the kinetic energy ek is equals to, from here actually we could write down half k is common term, and definitely this is a square minus x square, and we already have got all the value. So we could write down the ratio of ek over ep, and let's plug in the value. So it will be half k a square minus x square over half of k x square. From this equation actually, from here we could write down the value of ep. Now half cancel out, k cancel out, so we could write down a square by x square minus x square by x square, and the left side will be ek over ep. Now ek is equals to ep, and now we plug in all the value of a will be 0.1 whole square, and x, the displacement from the quotient, 0.02 whole square minus 1. After calculating, we'll get here, from here we'll get 24 and ep. So ek is equals to 24 times. So the kinetic energy is 24 times to potential energy.